Hello everyone. We are solving question number 61 of GATE 2015 chemical engineering paper, and the question is the block diagram for a process with feedback control for the output deviation variable h is shown in the figure below. All the transfer functions are given with prefactor of s in minutes. A unit step change is made in the set point at time t equal to 0. The time required for h to reach its 50% of the ultimate value in minutes up to 2 decimal places is dash. So for the given process represented by the block diagram with feedback control, we have to find the time required by the output, that is h, to reach the 50% of its ultimate value. So to solve this question, first of all we will write the transfer function of the system and then find the corresponding equation corresponding to the output, that is h. Then to find its ultimate value, we can use the final value theorem to find its final steady state value, and then we can simply calculate the time taken by the system to reach the 50% of that value. So let's start solving the question. So we can write the relation, the transfer function between h of s and the input set point hsp of s as the numerator of this transfer function will be the multiplication of these three blocks. Since we are calculating the correlation between this and this term, it will become gc gf gp upon 1 plus, in the denominator we will be multiplying all of these three blocks plus 1. So it will become gc gf gp and gm. So all this term will be in s domain. So let us write the individual transfer function of each of this block and simplify the equation. So gc we have been given as 0.5s, g of f we can write it as 0.2 1.5s plus 1 to 1 upon 0.5s upon, we can write this as 1 plus 0.5s 1.5s plus 1 into 1 upon 0.5s into 1. So you can cancel this term and then we can simplify this as 0.2 upon 1.5s plus 1 upon 1 plus 0.2 into 1.5s plus 1. So this will become 1.5s plus 1 plus 0.2, and the numerator of both this term will get, the denominator of both this term will get cancelled out. So we can write the final equation as 0.2 upon 1.5s plus 1.2. This we can also write it as 2 upon let's just take 1.2 common from this. So that is, we will be having h bar s upon h sps is equal to 0.2 upon, let's take 1.5 common from this, it will become 1.5 s plus 1.2 upon 1.5. This will become 2 by 15 upon s plus 0.8. That is, we are having h bar s upon hsp. So in the given question we have been given a unit step change in the set point is made. So since we are providing a unit step change in the set point, that is hsp will become 1 upon s. So let's just replace it over here. 1 upon s is equal to transfer function we found out as 2 upon 15 upon s plus 0.8. Over here it is black. bracket, that is the output will be 2/15 into 1/s into s plus 0.8. Now to convert this into time domain, we need to take this inverse Laplace of this term, L inverse of h bar of s. So for that we need to simplify this equation into this partial fraction. So that is we can write this as 2/15 into a upon s plus b upon s plus 0.8. So now using this equation we have to find the value of a and b. So what we will do is we will first multiply this equation by s, and then we will be getting the value of either a or b. Then again we will be multiplying the equation by s plus 0.8, that is basically this term, and put the value of s is equal to minus of 0.8, and then again we will be getting the other coefficients. So that is basically we are solving this partial fraction to find the constants a and b, and we will be having, you can do this calculation, and we will be having a as 1/0.8 and b as minus 1/0.8. So we can put this value of a and b in this equation, and we will be having h bar s is equal to 2/15. A was 1/0.8, so 1/0.8 s. B was minus of 1/0.8, so it will become minus of 1/0.8, and we had s into s plus 0.8. Now we have to take the Laplace inverse of this term, so it will become h of t will be 2/15. So let's just simplify this further by taking this 0.8 common. So it will become 2 into 15 into 0.8, 1 by s minus of 1 upon s plus 0.8, and this will become 1 by 6, 1 upon s we are taking Laplace inverse of this entire term. Now it will become 1 by 6. Laplace inverse of 1 upon s will be straight away 1, and 1 upon s plus a is e raised to minus of 80, so it will become e raised to minus of 0.8t. So over here we are having our output equation, and to find the final value we can simply put t tends to infinity, and we will be having the value of h at steady state, or the ultimate value, as 1/6 into 1 minus e raised to minus of infinity. So this will become 0. That is the ultimate value. H upon infinity is 1 by 6. Now in the given question we have to find time at which h is half or 50% of the ultimate value. So it will become half of 1 by 6, that is 1/12. So you have to find the time at which the value of height, or h, is 1/12. So in this equation we can simply put h is equal to 1/12 and equate it to find the value of time, that is 1 minus of e raised to minus of 0.8 t. So this will become 1 by t is equal to 1 minus of e raised to 0.8 t, that is e raised to minus of 0.8 t to 1 by 2. So we can take log on both the sides, and it will become minus of 0.8 into 2 is equal to minus of 0.693, that is t is equal to 0.693. 0.867. So the time taken by the system to reach 50% of the ultimate value, that is 1 by 12, will be 0.867 units. So we will write the final answer as 0.867.